Hello students, welcome all of you at AriserTalent. So, how are you all? I hope you are doing absolutely well. So, we were on our chapter 2nd of the chemistry class 10, that is acids, base and salt, and until now we have discussed about the basic definitions of acids and bases. We have discussed about various acids and their uses in our daily life. We have also gone through the discussion of the classification of the acid based on their different properties. Now, in our today's lecture, we are going to discuss about the pH of a solution. So, our today's topic is pH. So, before starting about the pH of a solution, let us take a simple example. Have you gone to any marriage or any parties and we have eaten a lot of fast food and blah blah activities? Okay, so we have done what actually we have eaten so much of the food that the acidity in our stomach goes on increasing. This acidity has been increasing due to the excess of hydrochloric acid produced in our stomach. This excessive acid cause the burning sensations and irritation in our stomach. So reducing this stomach pain or irritation, what we will do, we will take an ENO. ENO is basically the antacid which provide the neutrality to this acid. So acid and base react with each other to give us the cooling effect known as neutral solution, and this reaction is basically termed as a neutralization reaction. So this will be the application of neutralization and pH of the solution that we have observed in eating of a food. It means larger quantity of food, excess of food, which cause the higher quantity of the HCl production in our stomach. So now we are on our fresh topic, that is pH of a solution. pH, in the word pH, P is basically a German word that is potens, and potens means power, and H means calculating the hydrogen concentration in the solution. So, if I am considering the pH, P is a German word. And this German word is basically potens. This is potens, and potens means power. It means calculating the power of H means hydrogen ions. We can say that we are calculating the pH of a particular solution. So this idea or this experiment was first concluded by a German biochemist known as Sorensen. So this idea was given by Danish biochemist and the name of the Danish biochemist was Sorensen. And what thing gave him the idea for the calculation of the pH of the solution? He was keen interested in calculating the pH of the beer. So he wanted to calculate the pH of the beer, and after calculating the pH of the beer, he came to the many of the conclusion. So he was much interested in calculating pH of beer. So this was the main idea of the invention, that he want to calculate the pH of a beer. Now what actually the pH is? pH means negative logarithm of hydrogen ion concentration in a solution. So what is the actual definition of the pH? pH means calculating negative logarithm of hydrogen ion concentration. if in the solution we are interested in calculating the negative logarithm of the hydrogen ion concentration, we can say that we are calculating the pH of a particular solution. So in simpler terms, we can write pH as P small h capital, negative sign, we will enclose the hydrogen ion concentration in the square bracket. As we are going back to our topic, I have earlier told you about the Arrhenius concept. In actually the Arrhenius theory, we have seen that the solutions which are capable of giving H plus ions are termed as acids, and the solutions which are easier to give OH minus ions are termed as the bases. Now, we want to calculate the concentration of the hydrogen ions. Is it all right? So we will enclose this in the square brackets, and we will take the negative logarithm of that ions. So what I am doing here, I will provide here log H plus ions, because we are interested in calculating the negative logarithm. So from this formula, we will observe that we will calculate the pH of a solution very easily. So this will be the formula of the pH. This formula is very important for the numerical problems. Now we can also write as pH is equal to 1 upon log hydrogen ion concentration. So what I have done here, I have substituted negative logarithm in the denominator side, and this quantity will become the positive now. So this will be the another formula. Now from this formula, we can conclude that the pH of a solution will be inversely proportional to the hydrogen ion concentration. So I can write here pH is inversely proportional to hydrogen ion concentration. It means if the hydrogen ion concentration is more, pH will be less, and if the hydrogen ion concentration is less, I can say that pH will be more, because there is an inverse relation between pH and logarithm of the ion. So I can say that if H plus concentration is higher, pH will be lower. pH will be lower. If H plus concentration is lower, we can say that the pH will be higher, because in both the terms there is an inverse relation. So these are the main 2 points of the conclusion, that is, if the pH is higher, H plus concentration is higher, pH will be lower, and if H plus concentration is lower, pH will be the higher. So this will be the 2 general conclusions we can derive from this equation. Now we can say that pH of a something or our body or anything we see in our environment lies between 0 to 14. So the range of the pH is 0 to 14. Now if I consider the range of the pH, I can say that if I am drawing a scale, that is of the pH scale, this is our pH scale. In this scale, we have set the maximum limits. If I am saying that here 0 lies, here 7, and here the quantity is 14. So we can say that if the solution is having a pH of 7, pH is 7, the solution will be the neutral one. This solution will be the neutral one. If I am saying the pH is less than 7 is considered in the category of the acids. So we can say that if the pH lies between 0 to 7, the category is known as acids. If the pH of a solution lies between 7 to 14, it means it is greater than 7 and less than 14. We will consider it in the category of bases. So we can say that this will be bases. So I hope this must be clear to you that at the 7 we will count the solution as a neutral one. So we can say that if the hydrogen concentration in a solution is the greater, pH will be the less, and if the hydrogen concentration will be the small, pH will be the greater. This will be elaborated from this formula. Now we will take in simple example for the calculation of the pH of a solution. But before that, the major points you have to remember I will write here, so you can copy it from here. Now we have some important conclusions. The important conclusions are: if pH is 7, we can say that the solution is neutral, and for the neutral solution, the hydrogen ion concentration that is H positive will be 10 raised to the power minus 7. Now, if pH is less than 7, we can say that the solution is acidic. If the pH is less than 7, the solution will be acidic, and I can say that the hydrogen ion concentration that is H plus ions, pH is less than 7, so the H plus ions will be greater than 10 raised to the power minus 7. Now we are on our third conclusion. If pH is greater than 7, we can say that the solution will be basic. It means hydrogen ion concentration that is H plus ions will be less than 10 raised to the power minus 7. So these will be the general concluded results for the acid, base and neutral solution. If the pH is 7, we can say that the solution is neutral one. If the pH is less than 7, the solution will be acidic. If the pH is greater than 7, we can say that the solution will be basic in nature. So this thing will help us to calculate the pH of the solution and help us to identify whether a substance is neutral, acidic or basic. Now we will take an example of different substances to calculate the pH of the solution, and our examples will be here. So we will see the different pH of the solution. So from this example, you can see here there are many examples here which have a different range of the pH. So I have told you earlier, when the pH is 7, we can calculate it as a solution will be the neutral one. Now we are moving to the acid character. Here acidity will increase, and on that side basicity will increase. Now we can see that here that if we are considering the urine or saliva, it means it will have a pH range between 6 to 7. If I am considering the pure water will be the neutral in form, so its pH will be the 7. If I am considering soda, its pH will be 4. If I am moving to more acids, that is hydrochloric acid, gastric acid, battery acids. So you can see here the battery acid will have a pH of 1. So on moving to left side, we can observe that pH will be less than 7, and if the pH will be less than 7, we can say that the acid character goes on increasing. Now we are on our other side. You can see here the seawater. Seawater contains some sort of impurities, so its pH will lie between 8 to 9. Now if I am moving to this side, I can say that the basic character will going to increase. So you can see here the milk of magnesia, baking soda, soapy water, all these will have a pH greater than 7. If I am considering the drain cleaner, it have a pH of 14. If I am considering sodium hydroxide, that is a strong base, it will have a pH of 14. So I hope this table will have been clear to you from the examples that how acidity and basicity will going to increase. Now we will understand the pH of a solution in more easier way. So our next example is this is the pH scale for various solutions. Now if I am considering the blood is having a pH of 8 here. If I am considering about the soap is a complete base, it means it is a solution or the mixture of potassium hydroxide or sodium hydroxide, it will having a pH of 12. It means on this side the alkaline nature of the substance will goes on increasing. I am again considering water is a neutral solution having a pH of 7. If I am taking vinegar is basically the acetic acid. This is acetic acid, pH having 3. If I am considering stomach acid, the acid produced in our stomach will be the gastric acid and the gastric juices, and it will be have a pH of 1. I have earlier told you that lemon, tomato, these also contain citric acid, malic acid, so these will be the acidic in nature. If I am considering about the battery is having a some sort of sulfuric acid in it, so the sulfuric acid will have a pH of 0. So this is the classification of certain sort of acids and bases. So this must be clear to you that how will the pH of a solution or the substance will vary from one form to another. So this is all about the pH of a solution. Now we will take one numerical problem to calculate the pH of a solution. So now we will take a numerical problem to understand the pH of a solution, that how the pH will be calculated for the numerical questions. So our first example will be calculate pH of 1m HCl solution. We have to calculate the pH of 1m HCl solution. 1m means their molarity will be 1m, or we can consider the molarity as 0.011. So I am taking here 0.001 m HCl solution. So we want to calculate the pH of this scale. So what we will do here, we will apply the formula for calculating the pH. We know pH is equal to minus log hydrogen ion concentration. So what we will do here, we will substitute minus log 0.0001 hydrogen ion concentration. I can write it as minus log 10 raised to the power minus 3. So from logarithm table, we know that this thing which is in the power can be substituted in the forward direction of the reaction. So we can write it as minus 3 log 10. So it is the rule of the logarithm table that the exponent will be substituted to the upward side. So minus minus plus, it will be 3 log 10. Now what happens in this case? We have to remember that the log 10 will be equal to 1. So the value of log 10 will be equal to 1. So it came out to be 3 into 1, that is equal to 3. So the pH of 0.001 mHCl will be 3. So the answer here will be 3. So this is all about the calculation of the pH of any solution. Now we can see that the pH will be the negative logarithm of the hydrogen ion concentration. But what happened in the case of the bases? We can also write the formula as pH equal to minus log 10 OH minus concentration. So now we will learn about the concentration of the OH minus ions, but before you can copy it from here. Now pH can also be calculated as minus log OH minus ions. So this will be the formula for calculating the pH of the hydroxide ion. So our formula converted into pH equal to minus log OH minus ions. Now we have one more formula, that pH of hydronium ions plus pH of hydroxide ion, their sum will give up 14. It means pH for H plus and pH for OH minus ions will equal to 14. So this will be our next formula for calculating the pH. So these two formula will be very important for solving the numerical problems, and you must have to remember this for the calculation of the numericals. Now we are going to discuss our next problem. So our next example is calculate pH of 0.0001 NaOH. Now we can see here we are provided a base here, so we have to calculate the negative logarithm of OH minus ions. So we will apply the formula pH equal to minus log OH minus ions. Now we have minus log, concentration of OH minus ion is given 0.001. So we will substitute here 0.001. We have 3 zeros here. Now we can write it as minus log 10 raised to the power minus 3. Now I have just suggested you a rule that the thing that is in the exponent will come forward. So I can write here minus 4 log 10 minus plus. So we will get 4 here, and I have just told you that the log 10 will be equal to 1. So I am substituting log 10 equal to 1. So what we will get here? We will get the 4. The 4 will be the pH of NaOH solution. So the correct answer here will be 4. So I hope from both these examples it will be easier to you to understand the pH of a solution and how will we calculate the pH of a solution. These are the 3 general formulas for calculating the pH of a solution. Now we are moving to our next topic, that what are the applications of the pH in our daily life. But before discussing that, I will give you a simple description about a very simple topic, that is universal indicator. So our next topic will be universal indicator. So our next topic is universal indicator. So students, in our previous lecture, we have discussed about the indicators. Indicators are those substances which give different color change in the different solutions. Now, we are on our next topic, that is universal indicator. Universal indicator is actually a substance which give the different pH value for the different solutions. It is a brown colored solution dissolved in some substance which will change the color if the pH of the solution will be the acidic, basic or neutral. So what is universal indicator? It is brown colored solution dissolved in some substance. And what it is giving? It is giving the different pH values. So universal indicator is basically used to judge the pH of a solution. By identifying the color, we can consider the substance as acidic, basic or neutral. Now what happens in case of the universal indicator? Here color and here we will get the characteristic. So we can say that we will get three color combinations here. Firstly, if I am getting green color, if we are getting green color, we can say that the substance is neutral, and the neutral substance will have a pH of 7. Now what we will get in the another part, if I am getting color that is blue or violet, I must say the substance will be base. If we are saying the color is red, if the color is red, the substance will be acidic. So the universal indicator will give the different color of the solution in the different cases, and we can say that if the substance is neutral, the pH will be 7. If the substance is basic, the pH will be greater than 7. If the substance is acidic, the pH will be less than 7. So in this way, by the help of the universal indicator, we can identify the characteristic of the substance, whether it is acidic, basic or neutral. Now we are proceeding to our next topic, that what are the applications of the pH in our daily life. So our next topic will be the applications of the pH. Now our next topic is applications of pH. So the first application of the pH will be in the case of humans that we are considering here. In some cases, we have seen that our body has a digestive system which is capable of producing a HCl acid. So hydrochloric acid is used for the digestion of food in the human body. But what happens if we eat too much of the food and indigestion occurs in our body will start secreting a much of HCl. Now this excess HCl will be removed by taking some antacids. These antacids will neutralize the effects of acid, and we have a variety of antacids available like milk of magnesia, ENO, etc., which will neutralize the effects of the acid, and the neutralization reaction will going to take place in our body. So the digestion of food in the humans is an example of pH, because the pH range of our body get disturbed. So the first application of pH will be in the digestion of food. So what happens in case of the digestion of the food? When indigestion occurs, our body will start secreting much of hydrochloric acid. Now, this HCl will cause the irritation and burning in our stomach. What happens in this case? There will be irritation and burning in stomach. Now, this burning sensation will be released or recovered by taking an antacid. Now, antacids are the substance which are reducing the property of acids and provide us relief. So, antacids we are taking will be the milk of magnesia, this will provide a relief, and what we will get neutralized effect of acid and base, and our stomach will feel relief. So this will be the neutralization reaction that occurs in our body, which is completely the application of pH and neutralization. Now we are proceeding to our next category of the application of the pH. In our next category, we have our next example, that is pH in case of tooth decay. So what happens actually? Generally, the pH of our mouth will be less than 7, because in our mouth there are teeth, and the teeth have a coating of enamel that is made up of calcium phosphate. Now what this layer will do, this layer will not dissolve any substance on it, but if the pH of this our mouth will be greater than 5, there will be the corrosion in our mouth, and this layer will start corroding. Then whatever we eat, it contains sugar, wheat, salt, etc. This will react with it, and our mouth will get a very unpleasant smell, and the layer of the tooth start decaying, that will be the corroded. So it must be suggested to clean your mouth before and after eating of the food. So it must be necessary to balance the pH of the mouth below 5. So that's why we are applying toothpaste while brushing, because the toothpaste will consist of the bases that will neutralize the effect of the acid. So pH in case of the tooth decay, what actually happens? pH of the mouth should be less than 5. But what happens? There is a layer of tooth that is called enamel. This enamel is basically made up of calcium phosphate. This layer will start corroded due to the excessive eating of sugar and sugar in our food items. Then what we apply? We will use toothpaste. This toothpaste will consist of a base that will react with acid to neutralize the effect, and we will feel some relief. So the pH of the mouth should also be kept below 5 only. If it will be greater than 5, then it will corrode the layer of our teeth. Now we are proceeding to the third application of the pH. The third application of the pH will be in our plants and animals pH sensitive. This will be the basic question, that are plants and animals pH sensitive. Now the first thing here is, the human beings can only survive in a pH range from 7.0 to 7.8. So for the human beings or living organisms, the pH range is 7.0 to 7.8. Now what will happen? If the rain occurs, the pH of the rain will be 5. pH of rain will be 5. The pH of the rain is 5, that's why sometimes we also called it as a acid rain. Now what happens in this case? During raining, this rainwater got mixed with the river water. Rainwater mixed with river water, and it slowly reduced the pH of the river water. So what happened in this case? The organisms that are living in the river will not get a sufficient pH to balance themselves, and these organisms will die very soon. So what happens in this case? pH of river water will reduce and soon the organisms will die. So this is all about the pH sensitive range for plants and animals. Now the basic question arises, is it possible to live on the planet like Mercury, Venus, etc.? So it is not possible to survive on these planets because the Venus will have a white and yellow coating of the sulfuric gases around it. So the pH range will not match with the pH range there. So it is not possible to survive on the planets. Now we have the next application of the pH. The next application of the pH will be in case of the soil. So our next topic is application of pH in case of soil. Our fourth application will be pH in case of soil. The fertility and the product growth of any of the component will depend upon the soil. The soil with larger fertility will grow a more amount of crops or products. So it all depends upon the pH of the soil. Every soil has a different pH value depending upon its concentration. So what we will do? We will collect the samples of the soil and try to find out pH of them. And try to find pH. Now what we will see, the pH will have a different value in different cases. So we will check the pH which is useful for growth of the plants. So in this way, the pH of the soil is another very important factor. Now we are considering our last application topic, that is of the nettle leaves. What happens in the case of nettle leaves? In case of the nettle leaves, what actually happens? The nettle leaves have a tendency to release the acid that is called ethanoic acid. This ethanoic acid, when touched to our finger or hand, it will cause the burning sensation in the skin. Now what happens in this case? We will take a dog tree leaf and apply and start rubbing on our hand. Then dog tree leaf will give us the cooling effect. So what happens in case of the nettle leaves? Nettle leaves will start producing ethanoic acid, and this ethanoic acid, when touched to our skin, it will cause burning effect, and this burning effect can be reduced by rubbing a dog tree leaf. So this will neutralize the effect of ethanoic acid and we will get a cooling effect in this case. So this is all about the applications of the pH in our daily life. So pH will have an effect on the digestion of the body. It will help us the soil. It will help in rivers, etc. for flowing water. It will have an effect on the nettle leaves. Now we are proceeding to our next category of the classification, that is called bases. I have already told you that bases are the substance which are bitter in taste and soapy in touch. So this will be the elementary definition of the bases. Now in the modern definition of the bases will be the substance which have a tendency to release OH minus ions are categorized as bases. So our next topic will be bases.